Okay guys, so we're moving into the pH and POH portion of the unit. So you should already have notes written on this, but we're going to be using a combination of all of the formulas for this unit, but particularly this pH and this pH plus POH equals 14. Okay, so remember that a pH of below 7 means something is acidic. A pH of above 7 means something is basic. So this first sample problem in sample problems 3 is asking us to calculate the pH of a solution, and we're given the hydronium ion concentration. So this is just straight plug and chug. So you're given on your formula sheet that pH is equal to the negative log of the hydronium concentration. This can also be written as the negative log of the hydrogen ion concentration. It's the same formula, okay? So pH equals negative log of 4.7 times 10 to the negative 11 molar. So if we plug this in, we get pH equals 10.32790. So if we look at our sig figs here, this is our only sig fig, which is a measured concentration, and that's 2, so our pH equals 10. So this is a basic solution. So a couple things to know. When you guys learned logs in pre-cal, you would have learned that logs have different bases here. All of these logs are to a base of 10. That's important because if we're given the pH, we can also calculate the hydronium or hydroxide ion concentration, which we'll do in the third question, okay? So next, we have to calculate the pH of pure water. So here you're gonna have to use two things from your formula sheet. So if you know that Kw equals, hi Daisy, yeah, thank you so much, thank you. If you know that Kw equals your hydroxide ion concentration times your hydronium ion concentration, and you know that these are produced at a 1-to-1 ratio because of this, thank you. Okay. So 1-to-1 ratio, we can assume that the concentration of hydroxide and hydronium here is the same. So if we also know from our formula sheet that Kw is 1.0 times 10 to the negative 14, that value is now equal to x squared. So if we root both sides, we get 1.0 times 10 to the negative 7 molar is equal to x, which is equal to the hydronium ion concentration. So once we have this, all we have to do again is plug and chug. So our pH equals the negative log of the hydronium ion concentration, which is 1 times 10 to the negative 7 molar. So our pH here equals 7, but just to prove it to you, negative log 1e negative 7 is 7. So it's really important here that you are using your, and also guys, we're using rounded constants here, like the value for Kw has already been rounded, so sig figs don't matter here, but it's a whole number anyway, but just in case you had that question. It's really important that you're using your EXP or your times 10 to the power of button. I know I've been stressing that all semester, but you're going to get some wonky values if your calculator doesn't know how to do order of operations and you have an exponent, a log, and you also have multiplication, so, and double negative values, please make sure you're using that to plug in this, okay? So this third question, this is why pre-cal is the suggested prereq for this, because you need to know that there's a log and then there's an inverse log. So for logs of base 10, the inverse of this formula, so if we know that pH equals the negative log of the hydronium ion concentration, this is a log base 10. So we also need to know, and this is not given on your formula sheet, we also need to know that to write the inverse of a log, it's a negative log, so we have a negative exponent. The base is 10, so then the base becomes 10 here. This is our formula for the inverse log. Okay, so 10 to the negative pH equals the hydronium ion concentration. You either have to understand how to get here from here, or you have to memorize this. It's not given to you, okay? So if the pH of a solution is 10.3, 10 to the power of negative 10.3 equals our hydronium ion concentration, okay? So 10, oh, clear. 10 to the power of negative 10.3 is 5.01187 times 10 to the negative 11 molar. So we've found our hydronium ion concentration. That does not answer the question. The question asks for the hydroxide ion concentration. So here we're going to pull back to our formula sheet. If I know that, there's two ways I could do this. So if I know that 14 is the pH plus the pOH, I could start by subtracting from here, and then instead of using pH, I could swap this formula for pOH. That's more complicated. Or I can do what we've just done and then use this kW value. So kW, which we know, equals the hydroxide ion concentration times the hydronium ion concentration. So if I have the hydronium ion concentration and I know kW is 1.0 times 10 to the negative 14, I can find my hydroxide. Okay, so 1 negative 14 divided by 5.01187 E negative 11 is 1.99526 times 10 to the negative 4 molar equals our hydroxide ion concentration. Okay, so we need to sig fig this. This is a rounded value for pH, but we're going to have to use it because we don't have anything else. So 10.30 is 4 sig figs, so 1.995 times 10 to the negative 4 molar equals hydroxide. It's rounded, but it's measured. You can measure pH, so we can still use it. Okay. I just want to show you the alternate way of doing this. So if the pH is 10.3, oops. The other way to solve this is if we know that 14 equals pH plus pOH, and I'm looking for hydroxide, then I could say 14 minus 10.3 equals my POH. So then 3.7 equals POH. So pH equals the negative log of the hydronium concentration, but POH equals the negative log of the hydroxide ion concentration. So these formulas are the same. We're just swapping pH for POH and hydroxide for hydronium. Okay, pH is a log scale, so it works either way. Now, remember that I have to use the inverse log here, so 10 to the negative POH equals my hydroxide ion concentration. So 10 to the negative 3.7 equals hydroxide ion. Oh, gotta clear that. Which, once again, is 1.99526 times 10 to the negative 4. Just to prove it to you, same value. Molar equals hydroxide ion concentration. So again, we had 10.30, so 1.995 times 10 to the negative 4 molar equals the hydroxide ion concentration. So we get the exact same answer with two mathematical derivations of the answer. So whichever one of these methods makes the most sense for this question in your brain, you can use. I don't have the answer key book yet, guys. Once I have it at home, I will upload the answer keys to all of your homework questions for you to check. Also, additionally, can someone please on Teams send me pictures of the remaining textbook pages in this chapter, because I don't have a textbook here yet either. Please and thanks. I hope you have a good day, guys.